This video demonstrates the proper procedures for conducting a soil density test by use of the sand cone method, as well as the procedures for the microwave method of drying soil. The bulk density of the sand is needed to compute the volume of the hole made in the embankment when running the sand cone test. This needs to be determined prior to using the test sand in the field. At the same time, it is imperative that the cone correction factor is also determined. The cone correction factor is the amount of sand it takes to fill the cone of the testing apparatus, plus it includes the space between the base plate and the surface of the test. The weight of the removed soil, along with the bulk density, are used to determine the volume of the test hole. The volume of the test hole is used to determine the dry density. Place the empty apparatus upright on a firm level surface, close the valve, and fill the funnel with sand. Open the valve and keep the funnel at least half full with sand during filling. When the sand stops flowing into the apparatus, close the valve sharply and empty the excess sand. Determine and record the weight of the apparatus filled with sand. The sand cone test procedure is to dig a test hole, place the sand cone over the hole, and fill the hole with sand. Once a test site has been selected, make sure it is level and free from loose material. Place the base plate over the smooth area and securely fasten it down with the pins included in the compaction kit. The next step is to dig a hole to a depth of approximately 4 to 5 inches deep and to the same diameter as the hole in the base plate. This depth should provide a proper volume based on the maximum particle size. Caution should be taken when removing the soil from the test hole so that none of the material is lost. A fine brush is used to remove soil particles that may be clinging to the auger, spoon, or on the base plate. As you are digging the hole, put the material retrieved from the hole into a non-absorbent, moisture-tight container. Make sure the container has a lid that can be securely tightened. Once all the material has been removed, seal the container to prevent loss of moisture. All of the soil, including any loose soil at the bottom of the hole, should be placed in the container. Great care must be taken to get the walls of the hole as smooth as possible, as this affects the volume measurement. Shape the bottom and sides of the test hole with the spoon used in removing the soil. When the test hole is ready, with the valve closed, invert the cone with the sand-filled jar in the center hole of the base plate. Open the valve so that sand flows down into the test hole. This part of the test should be done in such a way that the sand cone is free from any vibrations or disturbances during the flowing of the sand. Vibrations can affect the bulk density of the sand and decrease the accuracy of the test. Once the sand flow stops, close the valve and remove the sand cone apparatus. Next, weigh the container filled with the soil removed from the test hole. Record this weight. Now weigh the sand cone apparatus and record. The difference between the initial weight of the sand cone apparatus and the final weight are used in the calculations to determine the weight of the sand needed to fill the hole. A previously determined cone calibration factor is also used to calculate the weight of the sand needed to fill the hole. The weights are used to determine the volume of the test hole. The volume of the test hole is used to determine the dry density. The next step demonstrated in this video is the procedure used to determine the moisture content of the soil by use of the microwave method of drying soil. Take between 300 to 500 grams of the soil sample taken from the hole. Place the sample in a microwave-safe container that has a known tare weight. Weigh and record. As shown in this video, the microwave method of drying soil is being run in the field at the test location. The microwave is being powered with the use of a portable generator. Place the soil sample in the microwave oven and run the microwave for 3 minutes using the defrost setting. Remove the sample and stir it. Return it to the oven. Continue with 1-minute cycles of drying and stirring the sample. Weigh the sample after each interval. Stirring the sample aids in uniform drying. Stirring also helps you see when the sample is dry, since generally dry soil particles will not stick to a spoon. Continue drying until a constant weight is achieved. The time needed to achieve constant weight will vary depending on the type of soil, sample size, and the microwave. Complete the final calculations using the appropriate worksheet.